My name is Nathan Zavanelli, and it is my pleasure to introduce PhysioConnect Healthcare Cloud Services, an innovative, cloud-based IoT system that seamlessly integrates 4 skin-like, imperceptible electronic patches into one coherent platform for continuous health monitoring. I am a PhD student in bioengineering working with Professor Woon-Hong Yo, and my colleague Jared Matthews is a recently graduated master's student from our group. For this CDAIT challenge, our work seeks to tackle the problem of non-communicable disease identification and monitoring, specifically relating to postpartum disease in marginalized communities. Non-communicable diseases have become the primary source of human mortality and disability in the 21st century, accounting for over 70% of deaths worldwide. Medical infrastructure has proven insufficient in meeting the intensive needs of many patient groups, particularly in low and middle income countries. Current solutions fail for numerous reasons. First, hospital-grade monitoring, while highly accurate, is ill-suited for continuous monitoring and screening. Second, traditional wearables, while quite simple to use, do not provide data that is clinically significant and are highly prone to false detections. Finally, traditional patches, while offering better data than wearables, struggle for 2 primary reasons. First, they only measure one signal, whereas many signals are needed to detect disease. Second, they do not have a sufficient IoT clinical pipeline today to enable rapid disease screening at low cost. Therefore, we propose a new system based on skin-like wearable electronics integrated into a single cloud infrastructure that seamlessly collects data from 4 devices, analyzes the data in a cloud environment, performs machine learning in real time, and updates clinicians on findings in a simple report. The 4 devices we designed consist of a sternal patch to measure ECG, pulse oximetry, and skin temperature, a forehead-based pulse oximeter, a secondary ECG and cardiac mechanics monitor, and an ear-based pulse oximeter. By measuring pulse oximetry in 3 locations, we can use pulse travel timing to identify patient blood pressure. We then developed an extensible mobile application using the Google Flutter framework. Flutter allows for multi-platform development, meaning a single code base can produce applications for both iOS and Android, simplifying the development, testing, and maintenance of the application. The application interfaces with the 4 wearable patches to receive raw waveform data, provide segments of these waveforms to a cloud-based computation engine to process, display the results of the cloud computation, and upload the session's waveform data to the cloud for offline processing at the end of a measurement session. Google Cloud Platform and the closely related Firebase Software Development Kit, or SDK, were chosen for hosting and developing the cloud architecture for their well-supported integration with Flutter. This cloud service provides the computational power to process potentially many thousands of simultaneous waveform submissions for determination of cardiovascular metrics, for example, heart rate or respiration rate, in real time, which are then returned to the mobile device for presentation to the user or clinician. Secondarily, the cloud also provides databases for uploading waveform data and storing calculated biosignal metrics, enabling long-term clinical monitoring and decision-making. To access the cloud computation, an application programming interface, or API, was exposed to the patient's mobile device over the internet via an industry-standard representational state transfer, REST, interface. An automated processing pipeline was developed for handling patient uploads. Upon receiving an uploaded waveform history at the end of a measurement session, the cloud file store that received the file automatically calls a cloud-native function for processing the data. The entire system, including wearable patch, mobile device and application, and cloud platform, were validated in an at-home study with first-month postpartum Black women in collaboration with the University of Illinois, Chicago. A system of devices was provided to 20 patients classified by maternal health clinicians as belonging to a high-risk postpartum population. Over 40 hours of submitted data were processed without incident, showing that 1. The system is robust and deployable, and 2. That the data collected is clinically significant compared to gold standard alternatives. Thank you, and we look forward to any questions.